Alright, so as we move right along here at question number 28 and 29, we are still factoring the trinomial completely. So let's go ahead and, like we've been doing, we'll rewrite the original expression we had out to the side here to give us some additional room. Alright, plus 20. Alright, so question 1, we want to see, is there a GCF that we can factor out of the expression of the trinomial? I don't see one. So question number 2, how many terms are there? Well, 1, 2, 3. So that tells us we're going to be factoring the scissors method or AC method or trial and error. So let's go ahead and we'll set up our chart for the scissors method. And we're going to list, remember, the factors of our leading coefficient, the lead term with our squared, and the factors of our constant there at the end. And so let's go ahead and list our factors of 10. So 1 and 10, 2 and 5. And for 20, we have 1 and 20, 2 and 10, 3 doesn't work, 4 and 5, and that is it. All right, so as we've been doing, we always start with the factors that are closest together. 9 times out of 10, these will be, in some combination, the factors that work for you. But if not, you have a whole bunch of others that you can try to arrange in some combination. But let's go ahead and try these. So we have 2 and 5, and we'll try 4 and 5. And if that doesn't work, we'll try 5 and 4. All right, so by now, hopefully you're getting the hang of the scissors method. We're going to cross multiply. So 2 times 5 gives us 10. 5 times 4 gives us 20. Can we, in some combination, add 20 and 10 together to get a negative 33? No, I don't think so. So let's go ahead and, just for organization's sake, let's go ahead and get rid of that so it's not in our way. And now let's try this combination. Let's try 2 times 4. That gives us 8. 5 times 5. That gives us 25. Can we, in some combination, add 25 and 8 together to get a negative 33? Well, I think we can. If we put a minus with our 25 and a minus with our 8, negative 25 plus negative 8 does in fact give us negative 33. And so, remember, whatever sign you put with your cross product just bounces over. So we put a minus with each of these cross products, and so it bounces over. And now that we have our sign, we can go ahead and wrap the factors we were working with. And so what we end up with is now, be careful here because we have 2 variables here with our leading term, don't we? So we're going to have 2mn minus 5, and here we're going to have 5mn minus 4, and let's go ahead and write these out on one line, and 5mn minus 4, and there you have it, the factored form of the original trinomial of 10m squared n squared minus 33mn plus 20. All right, let's take a look here at 29. So we've been given 30x squared plus 25x minus 30. All right, question 1, is there a GCF? I do believe there is. Let's go ahead and take out a 5. And when we do that, we're going to be left with 6x squared plus 5x minus 6. And now that we've pulled our GCF out, we can go ahead and ask ourselves that second question, how many terms are we left with? Well, 1, 2, 3. So we're going to be using, again, either method that you prefer, AC, trial and error, scissors method. Scissors method here says let's go ahead and take the factors of our leading squared term, so 6. Our factors of our constant there, 6. So we're going to have 1 and 6, 2 and 3, and listing them again isn't too difficult. All right, let's go ahead. We're going to start with the factors that are closest together. So we're going to have 2 and 3, 2 and 3, And if this combination doesn't work, let's try 3 and 2. All right, so we're going to go ahead and cross multiply. So 2 times 3, well, that gives us 6. 3 times 2, that gives us 6. Can we, in some combination, somehow subtract 6 and 6 to get a positive 5? Nope, I don't think so. So these are not going to be the combinations or factors that we're looking for. So just to help us stay organized, let's go ahead and get rid of that work there, and we'll go ahead and try the next combination. All right, so 2 times 2, well, that gives us 4, and 3 times 3 gives us 9. Can we, in some combination, 9 and 4, or 4 and 9, subtract those numbers to get a positive 5? I think we can. What sign do we have to put with the respective cross products here, 9 and 4, to get a positive 5? Well, if we start with a positive 9 and to subtract 4, we'll end up with a positive 5, right? And again, whatever sign we put with a cross product is going to bounce over. Whatever sign we put with the cross product bounces over. And once we have that sign, we can go ahead and wrap the factors in parentheses, and there we have it. So we end up with 2, and we have our x, plus 3, and we have 3x minus 2, and lastly, let's go ahead and write this. Remember, do not forget, what was the very first thing we did with question 29? We factored out a GCF of 5, so you have to make sure you include your GCF as part of your final answer. So 5 was our original GCF, and then go ahead and list the terms that you came up with while you were factoring. Oops, minus 2. And there's the final answer, the factored form of 29, which was 30x squared plus 25x minus 30. All right. Hopefully, like I said, the scissors method is starting to become a little easier for you. If not, go ahead and do whichever method you prefer. I think what maybe I'll do is I'm going to go ahead and I'll run through all of the problems using the scissors method, and then maybe what I'll do is I'll go back once all these videos have been uploaded, and here and there I'll sprinkle in the AC method. So maybe I'll go back and I'll do 28 and 29 using the AC method and then upload it at a later date. All right, but I think for right now, just for time's sake and again, because I prefer it, that method, the scissors method, I'll go ahead and do these via the scissors method. All right, so that was 28 and 29. Let's go ahead and take a look at 30 and 31.